Hey, feeling good, like I should. When in dark, walk around the neighborhood, feeling blessed.
Let's take a look at our homework for lesson 6.23 part 2. These are problems 87 through 92. Problem 87 says to solve the equation, and it's very important. You know, we are getting to that point where we're not going to try and do this mentally. You've got to record your work. Now, you can guess and check if you want to just start plugging in numbers until you get the right solution for X. You can do that. That's the 5D process. But it's going to take you a long time. You know, you can see here both of our answers are negatives, and most people would start guessing with like X is equal to 1 or X is equal to 2. They'd start with positive numbers before they got into the negative numbers. So if you just follow the steps, okay, so we're going to start with distributive property, then we'll combine like terms, then we will add or subtract balance sets, and at the end we will do a division if necessary. Okay, so this becomes 5x minus 10 plus a negative 9. That is going to be equal to negative 7, and a negative times a negative is going to give you a positive 7x. Now we will combine like terms and make this 5x, and I'm going to just change that to minus 19 instead of plus a negative 19. And here, maybe I'm going to rearrange these and call this 7x minus 7. Okay, so remember, you can rearrange the order of these. That's a negative 7, which is the same as minus 7. 7x, 7x. So it looks like we got x's on both sides, so I'm going to take away 5 x's from each side. So I will have a positive number of x's here, and at the same time, since I'm collecting my x's on the right, let's add 7 to each side so that I can zero out the negative 7. So we zeroed out the 5 x's and zeroed out the negative 7. Now we have to say, what is negative 19 plus 7? Well, it's a negative plus a positive, which means you're going to do a subtraction and keep the sign of the bigger number. So what number do you multiply times 2 to give you negative 12? Well, if you divide negative 12 by 2, you will get your solution, which is negative 6. So let's do a quick check to make sure that our answer is, in fact, negative 6. And I'll just do it up here. Part of it mentally. Negative 6 minus 2 is negative 8. So we're going to have 5 times a negative 8 plus a negative 9 is going to give you a total of negative 40, negative 49. On this side, you're going to have negative 6 minus, no, you're not. 1 minus a negative 6 is the same as 1 plus a positive 6. That becomes 7. And 7 times negative 7 is also equal to negative 49. That checks out. Our answer is negative 6. On the right-hand side here, let's go ahead and do distributive property. So this is going to become 9 plus a negative 2x, right? Because negative 1 times negative 9 is positive 9. Negative 1 times 2x is negative 2x. And on the left side, nothing gets simplified. That's already in simplest form. So I'm going to, if I add 2 x's to each side, that'll leave me with negative 4 x's over here. If I add 6 x's to each side, that'll leave me with positive 4 x's over here. I would rather have that. So I'm going to add 6 x's to each side so I can have a positive number of x's, which means I'll have to subtract the 9 from each side. To cancel these guys out, cancel those out. Negative 7 and negative 9 make negative 16. And now when we divide each side by 4, we get negative 4 is equal to x. So let's check it. Make sure we got everything right. We'll do it in green this time. What do we think is our, we think that x is negative 4. So negative 6 and negative 4 make positive 24. Positive 24 minus 7 is equal to 17. On this side, you're going to have negative 9 plus 2 times negative 4 is negative 8. Negative 9 and negative 8 makes negative 17. And when you multiply that times negative 1, a negative 1 times a negative 17 is positive 17. They are equal, which means x is indeed equal to negative 4. All right, a lot of work to be done in here. Why don't you just check your work? These are just practice problems. At this point, I'm pretty sure We've had a checkpoint problem having to do with fractions and decimals. We need to be experts at adding, subtracting, multiplying, and dividing all positive and negative fraction and decimal numbers. So this just gives us the opportunity to practice. Here, you don't need a common denominator because you're multiplying. Here, there's a process for multiplying two decimal numbers together. 4 and 3 make 12, and you got two decimal places. Here, we would need a common denominator, so we would change this to, I believe, times 8 over 8. So it's going to be 56 over 80. And then you add negative 63 to positive 56 to get our numerator. Here, we're going to have to add mixed numbers together and get common denominators. I'm going to go ahead and do B. And if you need me to do any other problem, just send me a line, email, ask me in class, whichever. I will work this out for you. But this is a little tricky, so I'm going to stack them. 5 and 1/9 plus 8 and 2/5. So we're going to do two parts. We're going to add the whole number part, and we are going to add the fraction part. So let's start with the fraction part. And let's add together 1/9 plus 2/5. Our common denominator is going to be 45. So we might as well just do the coat of arms. 5 times 1 is 5, and 5 times 9 is 45. 9 times 2 is 18, and 9 times 5 is 45. When we add those together, we get 23 over 45, which is in simplest form. 23 is a prime number, and it is not a factor of 45, so we'll just leave it how it is. And then 5 and 8 makes 13, so our total sum ends up being 13 and 23/45. Okay. Once again, if you need me to work out any of these others, please let me know. Sketch the parallelogram shown at the right, then redraw it with sides that are half the length. Okay, so that means that 6 units becomes 3, and the 2.5 units becomes 1.25. How do we know? Oh, it says it right there. Find the perimeter of both the original and the smaller parallelogram. So 6 and 6 is 12. 2.5 and 2.5 makes 5. 12 and 5 makes 17 for the larger one. And 3 and 3 makes 6. And 1 1/4. 1 1/4 makes 2.5. 6 and 2.5 is 8.5. Turns out, when you made the side lengths half, you also made the perimeter half the perimeter, because half of 17 is 8.5. Now, let's look and see what happens with the area. It says if the height of the original parallelogram was 2 units, then the area is going to be 12 square units, because parallelograms follow the formula of base times height. So 6 times 2 is 12. This would be 3, and that would be 1. Base times height is going to be 3. So you notice something happened here. When we took this and we scaled it down to 1/2 the original size, that affected the perimeter by making the perimeter half of the larger one. But the area, that is not half of 12, that is 1/4 of 12. So that'll be something worth exploring. Does that always happen? Is there a pattern here? Is there something that we can use like a formula to figure out what the new area is going to be when you scale something either by half or by doubling or by tripling or whatever? All right, evaluate the expression for x is equal to 2, then 1/2, then -2. So we are going to take this value and plug it in here and then work through the order of operations. 10 minus 2 times 2 is 10 minus 4. That's how you get 6. When we take 10 minus 2 times 1/2, 2 times 1/2 is 2. No, it's not. It's 1. Half of 2 is 1, and 10 minus 1 is 9. And then when you multiply 2 times -2, you get 10 minus a -4. And now this is where KFC comes into play. We don't like subtracting a negative, so we add the opposite. So it becomes 10 plus 4, which is 14. All right, set up a pair, or four, not a pair. Set up 4-quadrant graph. Set up a coordinate grid, a 4-quadrant graph, and graph the points below to make a 4-sided shape. So P is at -2, 4. Q is at -2, negative. Is that right? Oh, yes. -2, -3 is right there. Remember, I just made a little mental lapse. The x value corresponds to the first number, the y value corresponds to the second number. So on the x-axis, -2 is the value for x, and +4 for y, -2 and -3 for y, 2 and -2, and then 2 and +3. So what is this shape? When you've got two sides that are parallel to each other, that a four-sided shape with two sides that are parallel is called a trapezoid. Find the area of this shape. Well, that's the area of the trapezoid. So this is 7 units, this is 5 units. Those are the two bases, and the distance between the two bases is 4 units. So that would be the height. Okay, so sometimes we think height is a vertical measurement, but technically in trapezoids, height is the distance between the two parallel bases. And it just so happens that this trapezoid's been rotated so that the bases are not horizontal lines, they're vertical lines. So the height is now a horizontal line, but that's okay. So we're going to add these guys together and then divide it by 2 because that's how you find the average. So if I were to cut this guy right here and move this right here and move it to here, we would now have a 4 by 6 rectangle, which would give you an area of 24 square units. So that's kind of the logic of what's happening here with trapezoid. By finding the average of the two bases, we take away 1 from the 7 and move it over to here, and this becomes a 6, and this becomes a 6, so the average is 6. Half of 12 is 6, and 6 times 4 is 24. All right, what have we here? Write and solve an inequality for the following situation. Robert is painting a house. He has 35 cans of paint. He has already used 30 cans. So that means he's got 5 cans remaining. Now he needs to paint the trim. If each section of trim takes 1/2 of a can of paint, that literally means that you can do 2 sections for every can, which means you're going to be able to paint 10 sections of trim with 5 cans of paint. Okay, so this technically would be the inequality that you would set up for that. So 1/2 of a can of paint, where P represents the number of sections, and then 5 total cans. And you can't use more than 5 cans because you don't have any more. So you can use less than 5 cans. You could use 4, or you could use 3, or you could use 5, right? So the maximum number of sections of trim would be 10. And so notice how I wrote this inequality here. This would be the graph, because you can't paint less than 0 sections. So this is technically a compound inequality that would look like this. The fewest number of sections you can paint would be 0. You could just leave the 5 cans in the cabinet in the garage and not paint any of the trim. Or you can paint some of them, but not all of them. But you're not going to be able to paint more than 10 sections of trim because you've only got 5 cans of paint. Okay? Okay. And that does it for the homework. So let's move on to the next activity. Take care. Take care.
Hey, feeling good, like I should. When in dark, walk